command to start all the Dockers and they communicated with each other and then stop all of them at the same time. So that is where this Docker Compose comes into picture. And whenever you see in Hyperledger Fabric, they use Docker Compose files. That is the main thing. Then you want to spin up multiple containers for different enterprise applications. You take any applications or any kind of company, they use this kind of Docker Compose so that they even scale up the particular users or even load scale the the traffic coming from the users. So the main thing for blockchain that we have in Hyperledger Composer is these are the three different business concepts that we use in this Hyperledger Composer. One is the business network definitions. So the business network definition is nothing but how do you say your business works? What is your business actual idea about? So there are multiple applications for blockchain. For example, from food delivery to a particular retail homemade products, and even if you want to go for like internet banking, everything they use a business network and in the depth. So that business network should be defined clearly whenever you want to create a blockchain. So that's where you get to know the customer, what is their actual problem, and then you understand the business network. Inside the business network, we have different transactions, assets, participants, contracts, and a ledger. I think you guys have already went through the smart contracts thing. So let me explain about these assets, transactions, and participants and ledger. The assets are nothing but what does the business deal with? Like in case of a car vehicle manufacturer or a car auction, the asset is a
Excuse sir. Sir, your slide, we are able to see your first slide, sir.
your what's it?
Sir, we are seeing only your first slide, not able to see other slides, sir. I hope so.
Yeah, I'm discussing the second and first. I'm not able to see them.
No, sir. We are able to see only first slide.
Okay, let me just see.
Yes, sir.
Yep, it's fine.
Yeah, it's fine, sir.
Your presentation on Corona. Presentation. Please put on your presentation.
Okay, got it. So I should share the presentation one. Now is it fine?
Yeah, it's fine now, sir. Thank you, sir.
Okay. So yeah, so this is the application A, B, C, D, E, and F that I was talking about using Docker. And then this is the virtual machines that actually runs on different applications with different virtual machines. So if you see in a Docker, this is a single VM where you can spin off 6 kind of Dockers, that is 6 different applications that can talk to each other and work as a microservice architecture. But in case of Docker Compose, is the same thing that we say that using multi-Docker applications, using a YAML file, that's how we use this Docker Compose. So it is just a YAML file. I'll explain about it, how do we write it and those kind of things. So the current slide that we were talking about is the blockchain for business, the business networks, the assets, transactions, and then we have these participants. So I was in assets actually. So in case of assets, the car vehicle manufacturer network, the asset is a car. In case of food, in case if you take a food, for example, like a pizza, it comes from the manufacturer of the company. How does it get manufactured, processed, wholesaler, retailer? So in this case, the pizza is an asset. Each one has a particular ID, and that we generate by using this blockchain networks. Next is the transactions. So when you have a transaction, that is like when you buy a car, when you sell a car, and you kind of order a car for a manufacturing kind of thing. That is where transactions comes into picture, and the participants. So each organization is nothing but a company level, where each of the organization will have different multiple participants. For example, one would be the admin. That is the main thing of all the business networks. Admin should be given all the access rights so that you would be able to manage who comes in, who has the access to see what, and who has the access to write, read, and those kind of things. So even if you take off on any organization level, you'll be having participants. One is the admin part, second one is the sub-admin, and third one would be the participants, and maybe the fourth one would be some kind of a more privileged more than a participant. That is the customer. So customer can only view or read an order. That's the only thing. But all other participants can have their access to the business by creating a model, by creating a pizza or delivering it, those kind of stuff. The ledger is the main part. The ledger is nothing but a database. In case of blockchain, most of them would use level DB or CouchDB. That is where they use this ledger because it is a key value kind of a database, where you just have a key and a value. It's a kind of a NoSQL database. So that's why it's actually scalable and used across blockchain. So ledger is nothing but a database. It contains all of the transactions. As you know, blockchain is immutable. That's why they use this. So this replicated ledger concept, because no one can actually, do some malpractices in blockchain, because it stores each and every data that is actually shared across everyone. Just imagine if you know where your food is coming from, and when it has been created from the company, still is delivered to you. So that's where the ledger actually comes into place, and the blockchain as well. So you get to know the full life cycle of a food product from the start till the end it reaches your hands. So it's totally transparent, and everyone gets to know where there is no kind of, it's full transparent and very much useful for the customers. Let me just show you the use cases for blockchain. So these are the different sectors and different use cases in blockchain that are using right now in enterprise applications. And I see in blockchain, IBM is the one that actually going forward very high. So these are different things that they use. In case of agriculture, if you say smart farming, reduce food waste, food safety, other stuff. In case of healthcare research, and they're using nowadays blockchain with IoT as well. So connecting IoT with blockchain actually increases most of the sector usage in the future. Even in case of government, the voting system is going to be a blockchain soon. So the e-voting, which you say that there may be malpractices by the government, saying they may have done something in the e-voting system. But in using blockchain, you can use that, and no one would be able to do a malpractice, because each and every transaction is being ledgered, and everyone knows what is actually happening inside. And no one can even change the data. Even if they change, it would be registered there. So that's where this blockchain comes into place. It's totally transparent. Taxation, certificate exchange, healthcare, everywhere. Okay. So what is the blockchain actually today? What are the different enterprise applications looking at? What are they actually trying to solve these days? So everything that we do nowadays is for an enterprise as a developers or as a blockchain advisor. Smart contracts, that is a chain code, and it is distributed over a network. The smart contracts are everywhere, because everywhere blockchain is used as a sell and buy. As you know, the smart contracts will be useful to create trust over the customers and even the sellers. So there's applications that are built from the ground up, and we get to know the business network definitions. But if you take Hyperledger Fabric alone, it's a very big kind of a concept, and it's an ocean where you have to develop from the scratch if we have to do that. That's where this Hyperledger Composer comes into picture, where you just start the fabric separately and you write all your logic, your total assets, the participants, everything, the business network, everything inside the Hyperledger Composer. So we don't need to actually spend time on most of the other parts, like the access control, the particular error handling part, or the fabric taking too much of organizations, the giving the access level, those kind of things. We purely focus on business logic with Hyperledger Composer that actually increases our efficiency over the particular you know enterprise application, and even we get to know more usage. So this is how it actually reduces our burden of creating a blockchain application using Hyperledger Composer. So using Hyperledger Composer to the framework actually to accelerate the development of blockchain. As I told you previously, it contains of assets, participants, and transactions, those kind of stuff, and applications. So even if you want to write an API, even the Composer takes care of it. It even creates your Swagger doc where you can actually specify everything, and it creates APIs based on your transactions automatically. So it actually reduces a lot of pain for the developers and just focus on business logic. And it can easily integrate with the existing applications, anything. So for example, if there's a company that doesn't have blockchain but would like to implement them in top of over that business they already have, you can easily integrate them because the Hyperledger Composer is a tool where you can actually specify those contents and the business and the participants and then finish it up. Then they can actually use their existing DB as well as one of the connectors. So there are some challenges as well when we use this kind of centralized technology. When you have this kind of, when you have a centralized technology, why would they get to change to kind of distributed technology? That's where this cost cutting, everything comes into picture, where the blockchain reduces it. Because of centralized technology, it is not very transparent. Because I can do anything with my data in my database easily. There's no lack of visibility. There's no visibility to the user at all. That comes to the lack of visibility. I can do a fraud and data tamper. If a hacker comes in, you can do a fraud and data tamper, because if you see most of the companies, they don't actually encrypt the data. Even recently, there was a bank in US, a kind of one bank, I think. They got the data of the customers easily from S3 buckets. The one thing, it was because it was not encrypted, the hackers got it easily. So those kind of things can be easily solved using this blockchain, because each and every transaction is getting encrypted, and you don't will be able to hack that easily. And it has been proven that no one has been able to hack blockchains as well. So how does this blockchain work actually? The blockchain works based on the multiple nodes getting transactions getting through by these multiple nodes, and it is verified and is spread and distributed across the ledger. That is when the transaction actually gets complete. If a user requests a transaction, the transaction would go to a node. Nodes are nothing but, like, if you see, these are all different distributed ledgers. So for example, if you see, this one is node 1, this one is node 2, node 3, node 5, node 6, and node 8, those kind of things. If one of the user expresses a transaction, it will be going through some algorithms. So there's many algorithms in blockchain, like proof of concept, proof of consensus, everything. So we will use one of them as the enterprise application based on the business concept. And once we have this, there is deep technology inside this node itself. Each node has peers, each node has channels, each node has organizations, and each node has certificate authorities as well. So these will be used to verify whether the data is actually correct, and then do it and register the transaction, and then it will be completed. For example, if you take an e-voting system itself, if a user is registered, that is only when the transaction will get complete. And even if a user registers the vote a single time, the second time he won't be able to vote with the same name. So those kind of things would be actually helpful in blockchain, where you can actually verify that there is no malpractice going on with the same voter ID. So there is two kind of blockchains, right? One is private blockchain, other one is public blockchain. So when you use a private and a public blockchain is for overall public, that we won't be having actually, it's not much of a topic. This is the permission blockchain that we actually look for in enterprise applications. In case of permission blockchains, we can give it to an enterprise saying these are the different participants. As I told you, it restricts access on what the network should do, who should be able to access that network, who can be able to write, who can be able to read as well. The network is totally permission. And when the network is totally permission, the number of blocks or the number of identities that can approve a transaction would be less. So that's what actually increases the performance. Because of blockchain, as it is distributed, each and every transaction takes some time, which is higher than the centralized technology that is like using a single database. Because each and every time it has to go through all the nodes and peers and get updated through this pure ledger. So that's where a performance is it's only a slight increase in time, but it actually gives us a lot of other kind of, advantages over the existing technologies. And that's privacy and confidentiality. Even governance is enabled, it is interoperable, because we know who is actually accessing the data. Because without a particular digital signature or even a particular certificate for an identity, they won't be able to access the chain. There is a blockchain or the particular system network itself. So it's in total control for the enterprises who access the data. If you take big companies like Amazon, Google, everyone uses blockchain right now to keep the data safe. So the Hyperledger Fabric, it's kind of a framework that's actually developed by the Linux Foundation, where we use them for day-to-day enterprise application, where it's private and permission. But if you see like public blockchain like Bitcoins, Ethereum, these are kind of like a public blockchain where you don't have like particular framework for them. It's just a kind of a chain where you have to just keep on mining and getting data from that based on the particular algorithms they have. So Hyperledger Fabric is not the only one framework that has been developed by Linux Foundation. There are a couple of frameworks that they use, each and every one for different kind of use cases. They'll be using this based on our business applications. In case of, you see, Hyperledger, Iroha, it's an easy and modular thing that can be used for role-based permission models, where the company is basically on pure security, where they have this particular algorithm where they can create and identify these models and multi-signature support. They use Hyperledger, Iroha. Sawtooth, it is kindly for running, like deploying and running distributed ledgers, where Sawtooth is used for like an education platform nowadays, where they have this different kind of educations, videos, e-learning kind of things. They use Hyperledger, Sawtooth. And then comes Hyperledger Fabric, that actually allows the components such as consensus, membership, plug and play. When you have a particular company where you have members for that, when you have a sell and buy, they use Hyperledger Fabric. And Hyperledger Burrow is kind of an Ethereum, Hyperledger Indy. So these are different frameworks. We will mostly focus on Hyperledger Fabric and Hyperledger Composer. So there's Hyperledger Explorer as well, and there's Hyperledger Cello, Hyperledger Composer that I was been talking about. So Hyperledger Explorer is one of the things that we use that to create this API that I was talking about. It understands your query block, it understands your transactions, and it understands your particular assets, your participants, everything, and will create an API structure by itself, so that it's easy to understand how does an API look, how does a transaction work inside a business network. And the developers makes it easy because we can even test the environment in the Hyperledger Composer. Once you create a blockchain, it's very easy to test, and it's very easy to identify some kind of missing use cases, because that's always happens when you create or build an application. So that's where Hyperledger Composer comes into picture, and you can even deploy onto Hyperledger Fabric using that. So supply chain without blockchain. As I was saying, a food industry that we're talking about. So if you could take supply blockchain without using supply chain without blockchain, when you have these raw materials, they come from a factory and you produce them and you give them to suppliers, and then it goes to another factory and gets processed, goes to distributor, wholesaler, retailer, and consumer. So if you see here, each one of them has their own database, they have their own transactions, but they are not available across every one of them, where it is not transparent. Even the customer doesn't know when it got created or when they got processed and what is the actual expiry date of the food product. But what if customer gets to know where it got processed, where it actually started, and what is the date he has in his hands? Everyone gets to know about it. So now, if you see when using with the blockchain, this is how it looks when you have a blockchain in picture. So for example, the raw materials comes, it goes to the suppliers, they have a ledger. That ledger gets updated. The factory knows previously that the materials got into the hands of the suppliers, and factory gets to get ready to process. When the factory gets ready to process, the distributor gets to know based on the ledger. When they all have the shared ledger, it goes to the retailer finally, and even if you want, we can give the customer, there is a consumer, the read access to get to know where the food gets actually started and gets into your hands. So the data is totally transparent, visibility, immutable, and even traceable. And it's kind of real time and privacy and confidential. This actually reduces cost. It even eliminates the middleman to update the particular data from suppliers to factory, everything. It's all shared. So this is the power of blockchain that they use to actually increase the efficiency of the enterprise applications where it's totally transparent. But you can actually have these control of data that can actually be transparent and even non-transparent. Because if you take off financial enterprises, they have companies where they don't want to show some of the data because they are totally actually very confidential to the companies. In that case, you can control what data can be transparent over the network, what can be totally private and confidential. So coming to Hyperledger Fabric now, we'll go through a bit of how does it internally work, what are the different things that it has, like channels, organizations, peers, orders. These are just the internal working of the blockchain, how does it work and everything. But using the demo session, it's better to explain how does it work actually from the start to end. And even some of the advantages of using Hyperledger Composer, you'll be able to create an UI, a skeleton framework of a UI actually, where you're able to test it from the UI itself. So we use a package known as Yeoman, which actually creates a private skeleton UI where you can actually create and check your application working. So I'll explain them all of them one by one. Once we get to know the Hyperledger Fabric, the internal working, because getting to know a blockchain internal working, it goes from the Merkle root, the transactions, how does it know from the private key, the public key, everything. But Fabric as a framework, it works the same internally, but as a framework, we have different multiple, multiple programs that has been developed by this Linux Foundation. We'll understand them one by one. So this is kind of a highly modular and a configurable architecture where you can actually very easy to adapt to a particular enterprise application using this configurable architecture. And it creates a pluggable consensus protocols that can actually the platform to be very effective. High transaction is there in this, low latency as well, and no cryptocurrency to instance costly mining or to fuel smart contract execution. So mining is totally different from what we do from the private blockchain kind of thing. So that comes mostly into the cryptocurrency part when you go into mining. But for now, we'll focus on this enterprise things and how do we use this Hyperledger Fabric and Composer as well. So as I told you, ledger, this is one of the main thing that's actually in a blockchain, because if the ledger gets corrupted, it's a failure of blockchain. So the ledger that we use is kind of the state transition of an asset. State transition is nothing but how does an asset go through the flow. As I showed you the supply chain network using a blockchain, the asset goes from particular supplier, the wholesaler, the retailer, and then it goes to the consumer. So each and every transaction or the transition of that asset should be stored from the time, the date, the event, and the owner as well. The owner is nothing but the participants. So owner for the starting phase would be the suppliers, the raw processing kind of thing, and the second owner would be the distributor, third owner would be the supplier, and fourth owner kind of would be the consumer. So each and every owner, each and every transition of that asset is very important. And as it is only immutable, it is only happen only sequence and a tamper resistant record. The ledger cannot be actually tampered at all. So it is always having that shared architecture of the ledger. So whenever a ledger gets updated, it's actually getting distributed across all the ledgers. So even if there's a couple of networks, like for example, even if a supplier updates a new profit or new process for, it gets updated over all the ledgers. So everyone gets to know it's the starting point. It has started. So each and every channel. So channel, I will explain that what is that. So there will be one ledger per channel every time, and each peer is nothing but a node that maintains a copy of each ledger. So if there are 10 nodes, there will be 10 ledgers on each node. So as I told you, the ledger that we use, this would be CouchDB and even would be LevelDB. These are the two state database that can be used for transactions logs and even with the transaction IDs. So whenever you use a transaction log, it can create all transactions and immutables, and it uses the LevelDB kind of thing. So in case of state database, if you want to execute queries where you want to know kind of do analytics over your data, because nowadays most of the companies do analytics over whatever they have, like the customer base or even their particular products, or even how much sells, how much buys. They do analytics on all sorts of data as well. So they use this CouchDB kind of the state database where they can actually do a key value pair and do a lot of analytics. And this CouchDB enables us to do and execute complex queries as well, because these complex queries may contain each and every asset name, the participant ID, and based on that, you'll be able to know different kinds of numbers based on the asset. So for example, if you say a particular year and you want a particular data of a product that has been sold by this kind of geography location, so they will use that and get out the data for that particular location of Tamil Nadu. They got this is the product sales and this is the product buys, and this is the profit they had for the company. So everything would be non-immutable and stored in the CouchDB. So security is one of the main issues in most of the companies, where they don't have this handle transactions and who will be able to access what kind of data, because there may be any kind of error scenarios where the wrong person may be able to keep their hands on the data, which actually is a very loss for the company. So coming to this permission network, we have a card, not kind of a card, kind of an authorized signature for each and every identity in our case. So in case of Hyperledger Composer Fabric, we create an admin card or an admin participant each and every time to actually control over the network. And this admin actually creates other participants and the permissions rules for each and every participant. So kind of an entity. So here we call the participant as an entity. and we know the particular authentication known identities. So whenever a particular person or an author or an identity comes and do some changes, we know who is the identity that actually changed things in the network, because unknown one cannot be actually accessing the network at all without the particular identity. As you see in smart contracts, we have this digital signature network where without that we won't be able to access the network. And when you have transaction validations for each and every time, each and every participant would be carried out by a subset of those participants and validating the transaction on each and every node. And even the role assigned restricts the actions. For example, a role may give you only read, a role may give you only write, and it's kind of a SQL DB, giving authentications kind of thing. Same thing, but here we have this different kinds of signatures, and once if the participant or identity loses a particular digital signature, it may be used to reset, or you cannot be able to access the network unless you have an admin delete that card and create a new identity for yourself. So the privacy part I was saying, if for example, if a participant is available in a particular network, this happens in kind of mostly in financials, enterprise applications, where a participant is not visible to the public but can decide to disclose into trusted entities in mutable ledger. So for example, if you take auditing companies kind of thing, so you see a lot of auditing companies like KPMG and other stuff, where they need to access the client's data to audit stuff, but there won't be actually going through the core data. But in this case, you can actually control and give, because nowadays the data that I've been sending is using cloud and S3, those kind of things, but still it can be a particular problem in the client applications where they can misuse those data and keep it that by itself. But in case of this, a participant that has not been visible to the public but can be able to enterprise disclose their identity to the trusted entities. So if a KPI is a trusted entity, they can disclose this particular participant, saying you would be able to access only this readable information from this ledger, and we need to process data based on that. So this is where it becomes very useful in case of privacy and even confidential kind of thing. The participant is being exposed to only a particular set of data, and they can be controlled on what they can see and what they cannot. So every identity that we were talking about will be having a digital certificate in the blockchain network. And having a certificate it's like a signature key for them to access the network, as I told you before. And they have X.509 digital certificate, and they have the exact permissions in the blockchain Hyperledger Composer. We have this permissions.acl. That's a file that actually enables us to provide the access for each and every customer or the participant or the particular entity that can actually access what resources and can execute what transactions. You can even control that, like if an consumer can only execute a read transactions, but if a kind of a wholesaler retailer can add, that is write transaction. So those kind of things can be even controlled using this identity. And we have something known as MSP, that is a membership service providers. So as I told you, we can split this blockchain across different organizations as well. For example, if we have 2 to 3 enterprise applications using the same blockchain, each one has a membership service provider. So if organization A, B, and C are 3 different companies, and organization A has one MSP, organization 2 has another MSP, organization 3 has another MSP, each one would be able to provide that each identity for their employees, and they can access from that. So this should be a verifiable and trusted authority. And these 3 membership service provider are connected through channels. So that is where you know how to trust the other guy as well. So even if you access the other organization B's data, based on the identity, they will be able to know it is from that MSP provider, organization A, they're accessing the data. And that is how it becomes verifiable for an trusted authority. And even when you have a certification issue and revoked, so each and every time, it's a best practice to actually, kind of change passwords every 45 days. That's what they have. But in this case, we have certificates. We even need to issue and revoke them within a particular amount of time, because it may be compromised as well. But for in that case, we give best practices to keep it like around a month. You need to actually issue and revoke the certificate authorities, because the admin network, it's a kind of an automatic process where you can actually remove and then again create a new one every month, so that the customers or the participants in that won't be able to compromise the data or even the digital certificate. So as I told you, the MSP that we have uses this Fabric, uses XP 5.9, adopting a public key infrastructure. So in blockchain, we have something known as public key and a private key. So for example, if a particular person wants to send a message or wants to send a transaction to a particular person, they'll be using the two-factor authentication, where they're using the public key of the participant B and then encrypting with the private key kind of that, using the participant A and send it across. This transaction is being able to recorded by the CouchDB and the processed by the organization B. The participant B gets the transaction and he will be able to decrypt it using his private key. So using this public infrastructure and private key as well, it will be able to understand that this transaction is legit and it will be able to verify the transaction as well. But in case of enterprise applications, there's only a single time where they actually use this customer is valid inside the network. Once he comes in, he does a transaction. The transaction is almost saved everywhere, because it's kind of an application where it's not kind of sending a message or kind of thing. If you see, if it's like a chat providers, that is a different case where the message from A to message B would be totally based on encrypted data. And even to decrypt the data, you would be needing the private key of the receiver. So channels. These channels are main part in the Fabric network. This is the one that actually, it's kind of a subnet. Subnet is nothing but a place where you can actually connect through different peers and nodes and ledgers using this channel. It's a way of communication between two networks. That's it. So it's a private communication between two or more members for private and confidential transactions. In case of financial transactions, everything is confidential. We use these channels, but there's an internal network using Fabric. So each party using this would be authenticated and authorized to transact on the channel. So if you see this application 1, it goes through channel 1 and it goes through the P1, that is a peer 1, the ledger 1, and the service 1. So we have this particular channels installed on the Fabric network. And even application 2 uses channel 2. You can have multiple channels. And these channels can even communicate with each other. So that is how these channels are useful. So it is a kind of a subnet where you can actually use for communications. So these are the basic kind of applications or the internal working Fabric network. Now coming to peers and orders kind of things. So coming to the orderer and a peer. Peer is nothing but a node. In this case, if we have a client node and a transaction is being done by the client. Saying, for example, if you take a vehicle manufacturer network, where a client can request for a vehicle to be created based on what are the requirements he need. He can just design the color, the particular thing, everything. He requests his transactions and send it to the endorser. Endorser is nothing but a peer that actually understands your digital certificate and saying whether it's valid. That is a starting peer. And it goes to the orderer. Orderer is nothing but a service where you can actually update all the other peers based on the ordering network. If you have an orderer, that is where it is being used for ordering the other peers to get updated of the transactions. So chain code defines this endorsement policy. Chain code is nothing but a transaction code that we write. And the code that we use for writing these transactions are JavaScript mostly, because they have others as well, but here they have defaultly used JavaScript. So when you're having knowledge in JavaScript, you'll be able to easily understand these blockchain applications. So coming to this client node kind of thing and order kind of thing, if you say this is a peer node, and there's something known as gossip in a peer node as well. So if you see Hyperledger Composer has different peers as well. The peers can be classified into 4 different types of peers. So one kind of peers are, first one is the committing peer. So the committing peer is nothing but every node is a committing peer because it commits the transactions to the ledger. So the committing peer would be used for each and every transaction that the user does so that it gets updated across your ledger. So this ledger would be used to give transactions the particular identity and the particular immutable technology that we use using blockchain. So another peer is known as the endorsing peers. So endorsing peers are the one that we see the endorser that actually simulates transaction in the chain code containing and it's installed over these things. Next is the ordering peers that we saw orders, right? That is the one thing. They receive the endorsed transactions from the UI that is a client and package them to the blocks that we see. These ordering nodes keep track of all the transactions in the ledger, including the valid ones and invalid transactions. And there's something known as the leader nodes. So this something known as the leader or the admin nodes, that is the peers that we say is like an head or the leader that's used to communicate to the other nodes or the other peers. There is something known as static and something known as dynamic peers as well. So the static peer is nothing but the Hyperledger actually defines a single peer that actually says that he is the leader of that particular group and who would be able to communicate with all the peers. But in case of dynamic, the peers use a kind of a voting system inside the fabric and choose a kind of a peer that actually communicates with all of the peers. If a peer is down, by any chance, a node is down, they would actually use another node and create another node. A node is down is meaning nothing but an anchor. I mean a Docker, sorry. So this Docker is down, they'll be using another Docker by creating another one. That is where the Google Kubernetes comes into picture. So Google Kubernetes is used for this Hyperledger fabric as well. They use this in case of productionized applications where they use Kubernetes to create Dockers, and it is a very good backup strategy for node failures as well. Because just go through Google Kubernetes, because it is kind of an deployable architecture where you can actually control your production environment based on your data or your Docker applications, because it can even deploy your new update without even giving downtime to the customers. There is a very much advantage of this Google Kubernetes as well.
And we have this anchor peer as well. The anchor peer is nothing but there is a starting point where the order orders the peer to distribute the transactions. And there's something known as gossip. So gossip protocol, this is nothing but a messaging service that is actually continuous, and it maintains the receiving the particular transactions done by different users from multiple peers as well. So this gossip protocol is the internal working of how the peers leverage the data to be committed to the particular nodes or the ledgers each and every time. And this is the one that actually is highly scalable to keep those transactions under control. As I told you, it's the gossip protocol where each and every message is nothing but a transaction, where a channel is constantly receiving and current and consisting ledger data as well from multiple peers. So each gossip data that we send is being signed. Therefore, it actually removes the fake kind of users that can actually be able to get into this network. So as I told you, the anchor peer is nothing but that one that actually receives the blocks. Anchor peers update the other peers in the organization as well, set up at the channel level, and it is discoverable by other organizations. So we have different organizations, so each and every order would actually order to each and every organization, to the anchor peer, and then to lenders across everyone. And the leader peer would be sending up to all the committing peers, and they would commit the transaction in the ledgers. So using this order service is one of the main thing, because that actually orders the peers to update the data inside this Hyperledger fabric. So this is a kind of an architecture that has this order peers and this digital certificate authorities. So once you get to know this kind of architecture, it's easy for you to create a different organization or a multi-level organization, Hyperledger fabric, a blockchain network. So as I told you, the ordering service, it's kind of an messaging system that actually sends the transaction messages to different organizations, to the anchor peers. So if you have 4 organizations using a single blockchain network, this order is the main cause for sending the data across the different organizations so that the ledger is getting updated, shared equally. So it is responsible for the main consistent ledger state across the network. If any of the ledger state doesn't have the latest data, they fall to the order. So that is where this order is the main part, where it actually makes it even for the blockchain network, even for all the organizations, for the data transparency and understand the data in each and every ledger when it gets updated. So it ensures the order of transactions as well. So because each and every transaction is based on a synchronous manner, where one behind the one, if a transaction is happening based on 10 different customers, it would go and stay in the same way. It ensures the order of transactions happening same way, because it is not asynchronous kind of thing where you can have 10 parallel lines and can go to 10 times. It would go like different multiple orders giving to different anchor peers. So this is how the workflow works for the Hyperledger Fabric ordering service and order transactions as well. So this SDK is nothing but the Fabric SDK that they have developed by Linux Foundations, and the channels that we use to communicate with the particular ordering service. This ordering service would be using it to communicate to the order transactions into the Fabric, giving it to peer nodes, and update the ledger database. So just think of this as an message-oriented architecture that is the ordered peer, where it's responsible for sending these messages into the data. So in case of order, there are two kinds of options that are currently available to implement. One is a solo that is suitable for development, single point failure. Solo shouldn't be used for production as well. It should be only used for the development networks where you use solo kind of thing. It's a single point failure where it fails and it's gone. But you use Kafka, that is Apache Kafka, that is being used for a messaging system that is very much highly scalable and available. So it could be used for production ready environment using Fabric. So Kafka is a machine that is a high throughput fault tolerant failure. So it's kind of a very good feature in Kafka where it actually allows for an fault tolerant applications instead of using solo. So we recommend basically Apache Kafka for the productionized network using Hyperledger Fabric. So this is the overall transaction flow where it actually works, like how does it work for each and every peer and an ordering service. So for example, if you see a collect transaction is being endorsed into a valid endorsement policy, there is a chain code. It starts from here as the client C. And the first time it actually goes to the endorsing peer 1 and it checks and comes back to the next peer. Each and every endorsing peer checks the particular chain code validation and even the signed transactions. And once the verify endorsement is done and reads it OK, to reply the write set to state. State is nothing but the database. That is, it gives the message to the ordering service from the endorsing peer and actually goes to the ordering service. And from there, ordering service goes it to the anchor peer and actually changes it from there and comes to all the ledgers. So this is how the transaction flow of the total Hyperledger flow happens. So now this is the internal working of the Hyperledger fabric. This is how it's meant to be and this is how it's meant to be used using developed by the Linux foundations. Coming to Hyperledger Composer, how would we be able to do this over the network? So this is all already developed. This is just the internal working of the Hyperledger fabric. On top of this, you will be using your business network and creating particular transactions where everything would be dynamic based on your business network. The Hyperledger fabric will take care of your data, how it should be stored, what are the assets to store, what are the variables to be stored, everything. So coming to that part, in Hyperledger Composer, you have 4 different files that are actually important to be created as business network definitions. One would be the assets participant transactions that contain in the model file, and they have this .cto is the file extension where they use that for creating those models. And you have this particular transaction functions that I told you in JavaScript that they use to create this transactions to whether to update an asset or to create an asset or delete a particular asset kind of thing. So it uses the script file. Access control rules, I told you the permissions for identity guys, the participants, what are the permissions, how will they write, read, and those kind of things. And next is the query definitions. So as I told you, they use complex queries over the CouchDB as well to create and verify those queries from that DB. By using these 4, we would be combining them and creating a .bnf file. That is the business network definition file. We say the business network archive file. So from this network, to be creating an archive file, we will be using this archive file and be deploying it over in Hyperledger Fabric using Composer. So we have 2 different types of methods as well. One is using the Composer Playground, using the UI, another will be using the commands as a developer network. I prefer be going with the developer style where we have these different commands and other stuff where you can use this rather than the UI, because this the one actually helps out in case if you want to scale up with multiple organizations or even if you want to do it multiple peers and orders and multiple identities as well. So this is the total Hyperledger Composer concept where we'll be using these different things and creating a business network archival to be deployed on Hyperledger Fabric. So let's take an example of the core auction business network, where we can actually try to create a network and put it across the Hyperledger Composer. So in this case, let's say we have an owner, that is app, he sells the car. And there's something known as the vehicle registry, and we have listings registry as well. So these are the registries that actually have the data of each and every transactions of the car. So if you see this class is nothing but this is the business network name that we have, net.biz.vehicle.auction. Each and every business network will be having a name using a network style that is using dot, and we'll be creating them. And once we have this is the particular owner email ID, and each and everything will be having an ID. In case of an asset ID. In case of a buyer, it's a buyer ID. In case of participants, a participant ID. Each and everything will be having an ID for them that is unique for them. And once the particular owner sells or buys his car, it comes into the vehicle registry. Now we close the transactions that is actually happening using the sell offer bidding. Now the auctioneer clears the bids. So here, if you see, everything is transparent for the bidder and even this owner to sell the car. It's not kind of an untransparent deal. It's totally transparent, and everyone knows to get the other closest bid and will get to know the network. Kind of, they'll be able to identify the different bits that they have. It is a main concept, that is transparency, where in most cases they won't be able to see those bits where the other peoples are offering. The company may even fault or tamper the data and even increase their money for their profit. So coming to the developer toolset that I told you, these are the different developer toolset that we will be knowing in case of creating a blockchain network. So the first one would be the data modeling. That is nothing but the model.cto file saying what is the asset, what is the participant, what is the entity, those kind of things. Next is the business logic, saying what is the transaction that should actually happen inside them. Other is the web playground. So it's as I told you, it's the UI thing that we can do from the UI, creating a blockchain application. Then we have this composer client admin, npm client libraries, and you can do them using Visual Studio as well. They have these extensions for your Hyperledger Composer. And as I told you, the code generation for the UI is using your package. They generate a skeleton framework for the UI that you can use, connect with your blockchain network. And then over that, you can write all your UI stuff, like creating the CSS fonts or those kind of things. So the model files should be containing the assets, participant, transaction, events that exist in a business network. So it is kind of a JSON file that is fully validated by Hyperledger Composer. So this one would be having the relationship, the arrays, the validation rules, how whether a particular asset should contain a particular ID, or even if you take participants, you can even give the address, the pin code. You can use regex in the data modeling file saying this is the only values those it can support. So those kind of validations can be done as well. And the access control list, as I told you, the permissions for those lists. And even we have this transaction processor functions as well. So this transaction processor function is nothing but the logic that we write behind the additional business requirements. So this is how a particular model file would be looking like. The first thing in the model file is the namespace. Namespace is nothing but the network name. It could be given as network name, or it should give some other name, but it should contain organization, org, and a dot, and acme, and dot sample. So organization is always important in each and every network, but the namespace can be of any name. That is group related types kind of thing. And now we have this particular asset, participant, transaction, event. So these four are the same keywords that we'll be using for creating a model file. So for example, here first I should specify the asset sample set that it is identified by the asset ID. So asset ID should be specified inside the curly braces, and string asset ID and a string and a value. And this is nothing but the relationship that we give to the next, next definition. So if you see this arrow mark, it is a kind of an denoting a relationship to the other thing. So if a sample participant is actually connected to a sample asset, and he is the owner of that asset, that is the main thing. So each and every asset will be having an owner. So the participant is nothing but identify the participant ID. You'll be having participant name, the first name, and the last name. So each and everything should be identified by an ID. That is the main point over here. And each and everything would be having a relationship with the other thing. So if you take transaction, sample transaction, identified by transaction ID, it will be having sample asset as an asset. Sample event as well. It has event ID as the attributes old value, new value, and the sample asset that gets triggered by the sample event. So this is how a model file looks like. It will be complex for the bigger networks where you should be able to understand the business, how does it work. So I'll be showing you a demo of food supply chain and even another vehicle manufacturer life network. So it would be a better space to understand these model files. How do we write that? In case of access control list file, it will be looking like this. You can understand who can access the control list, and rules are executed in order to form from the top to bottom. So it should be like an ascending order, descending order, where you can, the main thing would be in the top and then it will come down by down. Each and every rule should be given kind of weight on the participant and the resource he can actually execute. So if you see here, everybody can read everything. Is a sample participant can read, and he can only read. I have given the operation as read and the resource as org.acme.sample. So he'll be able to read anything from across all the resources, but he won't be able to submit or even write. No access. So submit is a separate thing that he can create, and he can only trigger a particular transactions. Okay, if you see this transaction, sample transaction is there. So he'll be able to access that resource from that transaction, from that namespace. And owner, so he'll be able to see all the assets based on the identifier. So if you see this, we give the participant name as sample participant. Operation is all, not read and write. He has access to all. And the resource is the sample asset. And the condition based on what he is being done is the identifier is gets identifying using that. Now we have the transaction file that is a JavaScript with the logic.js. So it is using runtime API to interact with the blockchain APIs because it has already the defined functions. Is it asset registry or get new event, those kind of things. So once you get start or writing these code, it would be very much easy for you to create this process of functions and implement the registry APIs to add, update, and remove assets based on the blockchain world state. And it will use the APIs to publish events to the external applications, even for notifications or triggering downstream processing. So if you use this function sample transactions, you'll get an old value, we'll get a new value. So for example, if you take a sample transaction, we have an asset. If you want to update the old value, so we have the existing value, we'll update the old value with the new value, and then just give get asset registry, and we'll update it. So once you start writing this, the code is actually very simple because it uses a runtime API. You just have to pass the particular asset transactions and the name, and then you get to know the values. It will get updated in the word ledger state. So now once we create these three files, the business network definition gets created based on some commands. So it will give you the version of that each and every time you create a new archive file. And there's something known as package.json as well. You'll be creating each and every time you create a network definition. So this one is very important for the business network validations and creating a data business blockchain model on top of it. So it can be used for deployment. It will be used for deployment with the Hyperledger Composer over the Fabric. So basically, we do not convert it, or we compile and translate it into a smart contract code. For example, Composer does not convert those transactions, whatever we write, into Go code kind of thing. Composer has kind of a runtime which actually understands this code and executes the business network archival file. Then what they do, then they actually get them deployed together as our smart contracts. Because in smart contracts we have this Golang kind of thing, but in this case it has the business network definition and the composer runtime that are deployed together as is known as the smart contract. So together they use this and create a smart contract. And then this is how the execution happens easily. So you have the blockchain world state. So this client calls the Composer Node.js client API, a Composer REST API that I was telling you about, and they go through the consensus. They have this transaction processor call and score the blockchain transactions. So this is how the execution actually happens in the total blockchain network of the Hyperledger Composer. Now, these are the Composer steps. First thing, to start a Composer and start a blockchain network is to first start the fabric. So once you install a Hyperledger Composer prerequisites, it would be asking you to start the fabric network first. So you'll be starting a fabric network and it will be getting running used on Docker applications. Now you have the business network archival file. This business network archival file will be deployed over the fabric network, and we have an admin card generated for this business network alone. For example, if you have a food supply chain, there'll be a separate card that is the admin for food supply chain. You'll be using that signature for all the transactions in that Hyperledger Composer. And then you will be starting a REST server that is exposing these transactions as an API. And then, as I told you, you're using Yeoman package, you can create and generate an Angular app. It's a skeleton framework where you can actually access those APIs easily. So this is how basically a Composer REST server looks like. Once you create a particular network, it will be showing you there's an asset named commodity, there's a system, there's a trade, there's a participant named trader, and it will be showing you all the listing operations, that is API, get, post, put, delete, everything. Now based on this, you need to create, you can use these APIs, or you can create an API, you can create an UI and then use these APIs inside those UI. So this is a Hyperledger Composer solution that we have. So if you see the supported runtimes in the below, it starts from there. It has the Hyperledger Fabric, Web Embedded Node.js, and goes to the Hyperledger Composer. We have a Composer REST server, a web playground, and a Composer client. And then using skeleton app, calls a REST API generated by Composer REST server, creates from Angular, and that Angular is being generated by the Yeoman. This is how the Hyperledger Composer solution looks like. When you want to create a particular solution using Hyperledger Composer on a fabric, this is the first thing, like in Hello World and C code, this is the first thing in the blockchain for Hyperledger Composer. And then from that, you'll be able to understand the UI, and then you'll be able to develop them into a more fascinating UI and even create more functions and even transactions in the backend as well. So let's take an example here. For example, this is the vehicle kind of an vehicle manufacturer network, where once you issue a car, you know that a car gets manufactured and the buyer is there. And then we have this regulations, that is the RTO that we say, that we use to know what car has been issued to what issuer and those kind of things. So instead of going and starting to give applications to each and every participant, what do you think if they shared a common ledger where everything is being automatic, where everyone gets to know that car is being manufactured and Paul is the buyer or the owner of the car, and Debbie is the kind of VDA regulations administrator, where she knows that a car is being issued, and then it would be assigning an insurance policy or kind of regulations for that car. So let's see. So we have these three participants over here using blockchain network. They would be able to create less minimal time and more efficient kind of delivery to the customer, and the customer gets to know what is the process happening. Actually, he gets to know whether the car has been manufactured, whether it's been passed to the logistics, and whether it's been delivered, and whether it's been registered on his name, and whether it's been done acknowledged by the regulations administrator as well. So the customer uses a mobile app that is using ordering a car, and then using enterprise integration tools, he uses an ERP tool and then just orders a car that he wants in this kind of format and those kind of things. And now Debbie gets to know about the business rules and what is the applications that they have. This is how the particular blockchain will be helping them to create, instead of going and submitting. Once the Paul submits, now Mike gets to create an application. Customer doesn't know what is happening. When he gets delivered, he needs to contact Mike, and each and every time that's a middleman cost for customer supplier, customer care. And then Mike needs to go to the VDA, Debbie, and saying this is the particular car that's been issued to Paul, those kind of things. But once you think everything is connected to a blockchain network, everyone gets to know what is happening in the total world, which is transparent, and everything goes smooth, and which actually increases the efficiency. So I'll be showing a demo based on this and with supply chain. Yeah. So that's it for Hyperledger Composer as of now. If anybody has some questions, I'm ready to answer.
Hello, sir.
Yeah.
Hello.
Yeah.
Audible?
Yeah, you're audible, yes.
Yeah. So, tell me which platform is better to implement, like Ethereum is there, Solidity language, or Hyperledger. So, in which language we have to prefer if we want to
In this
develop
case,
any
we
software
prefer,
application?
yeah. So in case of Ethereum, we have Solidity, right? Where you use Solidity to keep that and create an application using Ethereum or the particular transaction or wallets you have. In this case, we prefer JavaScript as it supports JavaScript and Golang or Golang. So it uses this JavaScript that is actually very much
Okay.
preferable using this Hyperledger Composer, and very much easy to deploy and understand them. Even they're trying to build up in Python as well, but I think it's still in a very archival mode. They need to go out for Python as well, but for now they support full support in JavaScript. Yeah, the role of Fabric SDK, Rajit, is like an API kind of thing. So SDK is nothing but a software development kit where you have an API that gets exposed to the Fabric. How do you think this particular composer gets connected to the Fabric? Because Composer runs on over a Fabric. Now the Fabric uses this runtime API and gives us this SDK that we use in the Composer, in our transaction that we write, and gets updated in the ledger to the Fabric. So that is where this role of SDK Fabric comes into picture. And I will share the PPT to everyone, and even I will share my demo to everyone as well. So it would be in my GitHub links. And yep. So any other questions?
Yes. Thank you, Ashok. Can we proceed the next session by 11 o'clock? 11:30. We'll meet again by 11:30.
Yeah, sure, Blessa. Yep.
Okay, Ashok. Thank you so much.
Okay, so Natasha asked about difference between Hyperledger and Ethereum. So I think Hyperledger and Ethereum both are different based on the private and public blockchain that I told you. So Hyperledger Composer is like a framework that has been used for enterprise, that is companies, to build on, concepts based on their problems. But if you see, Ethereum is a public blockchain. Even Bitcoin is a public blockchain. It's not based on a kind of Hyperledger framework. It's not privatized. It is public. Even you can start mining, or you can even start buying in Ethereum. But in case of Hyperledger, it is totally closed inside a company, and you can't even access the network. So there is a main difference between them. Yep, sure guys. So let's meet at 11:30 and I'll be showing a demo of how to use it. Yep. Thank you.